So today we shall be looking at chemistry, all right? And then the topic we shall be considering today is balancing of redox reaction. Redox simply means reduction oxidation. Now, if you want me to treat this topic in full, reduction oxidation reaction, you can drop it in the comment section and I will do justice to that. So today we want to see how to balance this redox reaction. So what's the first step here? I'm going to start by writing C2O4 2 minus CO2. Okay, then I will look for the oxidation number of carbon in this compound, okay, and also the oxidation number of carbon in this compound as well. Now this is 2, right? 2 times C, that is 2C, plus oxygen here has a valency of -2, so -2 times 4 equals to -2. Okay, now 2C plus -2 times 4 is -8 equals -2. 2C plus times minus is minus. -8 equals to -2. So -8 comes here. I'm having 2C equals -2 plus 8. 2C equals to 6. Divide both sides by 2. This cancels this. C equals to 3. C equals to 3. So the oxygen number of carbon here is 3. Now let's check for this. C plus -2 times 2 equals 0. C plus -2 times 2 will give us -4 equals 0. Plus times minus here is -4 equals 0. So C equals to -4 comes here, it becomes +4, right? So here is +3, here is what? +4, right? Now, is it an oxidation reaction or a reduction reaction? Now let's see. Now, one of the definitions of oxidation is that there is an increase in the charge. Okay, now if you check here, now here is +3 and here is +4. So that means the charge has increased. And apart from that, if you want to define oxidation in terms of electron transfer, oxidation is the loss of electron. Now let's see. This is +3 and this is what? +4. Okay, so +3 minus +4 will give us what? -1. So that means the electron here is -1. Okay, so if you check here now, there is a loss of electron due to the what? Negative value of the electron here. So from the definition of oxidation in terms of electron transfer, that states that it is the loss of a what? Of electron. So it shows that what? It is an oxidation what? Reaction. Okay, so this is what an oxidation reaction. Now let's see. Now, one of the definitions of oxidation is that there is an increase in the charge. Okay, now if you check here, now here is +3 and here is +4. So that means the charge has increased. And apart from that, if you want to define oxidation in terms of electron transfer, oxidation is the loss of electron. Now let's see. This is +3 and this is what? +4. Okay, so +3 minus +4 will give us what? -1. So that means the electron here is -1. Okay, so if you check here now, there is a loss of electron due to the what? Negative value of the electron here. So from the definition of oxidation in terms of electron transfer, that states that it is the loss of a what? Of electron. So it shows that what? It is an oxidation what? Reaction. Okay, so this is what an oxidation reaction. Back to this. MnO4 minus, Mn2 plus. Now, let us also check for the oxidation number of manganese here. Let's go. Remember that what? The valency of oxygen is what? -2 times 4 equals to what? -1. So Mn plus Minus 2 times 4 gives us minus 8 equals minus 1. Mn plus times minus is minus 8 equals minus 1. So Mn equals minus 1 plus 8. Mn equals 7. Okay, so the oxidation number of manganese here is 7, and here it is plus 2. So I'm having here as plus 7 and here as plus 2. Okay, now we have concluded that this is what an oxidation reaction. What about this? Now let's check. Reduction is a decrease in its charge. Okay, so let's see. Here is plus 7 and here is plus 2. So there's a decrease in charge. Okay, and in terms of electron transfer, it is an increase, okay, in electron, or yeah, a gain of what? Of electron. Now let's see. This is plus 7, this is plus 2. So plus 7 minus plus 2 gives us what? Plus 5. So I'm having it as plus 5e minus. Now, from what you're looking at here, this is plus 5. So it shows that what? There is what? A gain in what? In electron, or an increase in the what? In the number of electron here. So it is what? A reduction reaction. All right? If we check the value of oxygen on this side and the value of oxygen on this side, okay, they are not the same. So it shows that oxygen is not balanced here. Okay, it's not balanced on both sides. Okay, this is 4, oxygen here is 4, oxygen here is what? Is 2, so it's not balanced. Carbon is 2 here, carbon is 1 here. It's not balanced. So what do I do? Now, because of the 2 here attached to what? To carbon. Okay, so I'm going to put 2 here and then 2 here. So let's check if it is balanced. Okay, carbon is 2 here, carbon is 2 here, carbon is balanced. Oxygen is 4 here, oxygen is 4 here. 2 times 2, that is 4. So oxygen is balanced, on both sides of the equation. Apart from oxygen, carbon too is balanced on both sides of the equation. Now, but if we come here, this is manganese. Manganese here is 1, manganese here is 1, manganese is balanced. Oxygen here is 4, but there is no oxygen here. So what do I do? Now, if you have this kind of redox equation or redox reaction, okay, and then there is oxygen on one side and there's no oxygen on the other side. So the best thing for you to do is to introduce what? Hydrogen. Okay, so I'm going to introduce hydrogen here. Okay, the reason why I'm bringing hydrogen here is because hydrogen will react with oxygen to give us what? H2O. Okay, so if I have H here and there's an oxygen here, so it means that I'll be having what? H2O here. Okay, now let us see. This is 4 oxygen. Okay, this is 1 oxygen. So what do I do? I'm going to put 4 here. So I'm having 4 oxygen here, 4 oxygen here. Okay, 1 manganese here, 1 manganese here. Then 8 hydrogen here, 1 hydrogen here. So I'm going to put 8 hydrogen here. So hydrogen is balanced on both sides. Oxygen 2 is balanced on both sides. Manganese 2 is balanced on both sides. Okay, but if we check the value of the electron here and here, they are not the same. So what do I do? Now I'm going to multiply here by the 5 here. Okay, then I'll multiply what? Here by these 2. Okay, it's just like you are applying elimination method whenever you're solving simultaneous equation. That's exactly what we have done here. Okay, so we want to make the value of the electron, in the oxidation reaction and then in the reduction reaction to be the same, so that the electrons can go off. So that's why I have to multiply here, okay, by this 5, and then multiply here by these 2. All right, okay, so let's go. 5 times 1, here is 5, so let me draw a line. 5 times 1 here is 5, so 5 C2O4 2 minus 5 times 2 is 10. Okay, 5 times 2 is 10 CO2. Okay, so let's check. 5 times 2, that's 10. So 10 carbon, 10 carbon. Carbon is balanced on both sides. Let's check oxygen. 5 times 4 is 20. 10 times 2 is 20. Oxygen 2 is balanced on both sides. Okay, so let's come here. 2 times 8 is 16. That's 16. H plus then 2 times 1 is 2 MnO4 minus, then 2 times 5 is 10E minus, then 2 times 1 is 2 Mn2 plus, then 2 times 4 is 8H2O. Right, so let's check also. Now, this is 16 hydrogen. 8 times 2 is 16. So hydrogen is balanced on both sides. Let's check manganese. This is 2 manganese, 2 manganese. Manganese 2 is what is balanced. Let's check for oxygen. 2 times 4 is 8. This is 8 oxygen. Oxygen 2 is what is balanced on both sides. Now, let's check. Now, the idea here is to take off the electrons. You can see that the electrons are the same. Okay, so I can strike them off. Okay, so at the end of the day, what do I now have? Now let's check. So I'll be bringing this and this together. So I'm having 5C2O4 2 minus. Okay, then I'm having 16H plus, then plus 2 MnO4 minus. Okay, then come back here. This is 10CO2 plus this 2 Mn2 plus, then plus 8H2O. Okay, so let's check. 10 carbon, 5 times 2, 10 carbons here, so carbon is balanced. 20 oxygen, that's 5 times 4. Then 2 times 4, 8. So 5 times 4 is 20, 2 times 4 is 8. So 20 plus 8, that's 28. 28 oxygen. Okay, on this side of the equation, let's check here. 10 times 2, that is 20. Okay, then this is 8. So 20 plus 8 oxygen here is 28. So oxygen is balanced on both sides of the equation. Now let's check for hydrogen. This is 16 hydrogen. 8 times 2 here is what is 16. Hydrogen 2 is balanced on both sides. Now let's check for manganese. Manganese is 2. Manganese is 2. Manganese 2 is what is also balanced. All right. Now that alone cannot determine if the redox reaction or the redox equation is balanced. Okay, you still have to check out for the charge. Now let's go. Now, if you come here, this is 2 minus, and this is 5. Okay, so you multiply 5 times minus 2. That gives us what? Minus 10. Then, this is plus 1. So, 16 times 1 gives us what? That's plus 16. And then, this is minus 1. So, 2 times minus 1 gives us what? Minus 2. Okay, so let's see. Minus 10 plus 16 gives us what? 6. And 6 minus 2 gives us what? 4. So I'm having 4 here. Now come back here. There is no charge here. There is no charge here. Okay, so this is plus 2. 2 times plus 2 gives us what? Plus 4. So you can see that the charge is balanced on both sides, or the charge are the same, or the charges are the same on both sides of the equation. Okay, so it shows that what this particular redox reaction is balanced. Okay, so it's not difficult. Just follow the steps and then you arrive at the answer. Okay, so if you want more on this, you can check my YouTube channel, and then you will see more questions on this, solved questions on redox what reaction. Until next time we will meet, bye bye.